Good evening, everyone. My name is Kiran Kumar Sonati. So today we will discuss about the assignment 4 which I have done, which is on the course topics in operating systems. So in the assignment 4, which is on the title name, communication in IoT and operating systems, advancements, challenges, and a conceptual framework, UAVs, IoT communications. So as you can see in the report which I have shared the screen, this is the report which I have done based on the analysis of the articles provided and whatever the knowledge which I have gained. So based on the knowledge which I gained, I prepared the report which will be helpful. So when coming into the introduction of this, so the connection between IoT gadgets and underlying operating system is paramount for enabling an effortless data exchange and highly efficient operations in IoT infrastructure. So, if there is the connection between the IoT gadgets and the underlying operating system is efficient, then there will be a good communication exchange between these devices. Moreover, it won't be much impact to this any of it impact to the communication, so it will be helpful. Thus, this report else plans to look into the shared topics, difficulties, and progressing in IoT communications and operating system. In addition, it examines the application of unmanned aerial vehicles to accomplish extremely dependable IoT communications. Through a group utilization case, this report speaks to key discoveries from, the stru- from the research papers, constraints, the strategies, and the technology is talked about, and presents a conceptual structure to manage obstacles and employ efficiency and dependability. By exploring the perplexity and rustiness, the paper plans to highlight the importance of information complexity and variation in ensuring reliability and efficient communication IoT environment. So, as introduction shows that the communication need to be efficient so that there will be proper communication between the IoT gadgets. So there won't, if there is no impact to the communication, then will be the efficient data transfer which will be happened. So that is the introduction. Next, go to the literature review. So the literature review on the IoT communication and operating system reveals certain widespread themes. The necessity for dependable connections, interchangeable data, secure communication, and judicious research utilization. Sealing heterogeneity, energy efficiency, and data privacy, and there are several of the obstacles to be conquered. So as we can see, scalability and heterogeneity and energy efficiency and data privacy need to be the challenges which we need to face and solve those issues to get into this solution done. So consequently, many effort has been made to overcome these difficulties. For instance, cutting intelligent papers emphasis emphasizes the development of protocols like these are the protocols MQTT and COAP which promote lightweight and reliable message among the connected devices and the operating systems. So furthermore, advances in M2M communication, including functionality for discovery, service provisioning, and adaptive change have further the overall efficiency of the IoT framework. This is the literature review, so this is actually explains about the what are the challenges which we need to get in conquer to get into proper solution, and we need to. These are the challenges like energy efficiency, heterogeneity, and scaling, and data privacy are the challenges which we need to have the solution to get it into make the communication properly done between the IoT devices. So this is introduction. So let's getting into the key findings and insights from research papers. So in the when you get into the first one in the paper, this paper focuses on the challenges of IoT data interoperability and proposes a semantic interoperability framework based on the ontologies. It highlights the importance of the common vocabulary and semantic model to enable the effective communication between devices and IoT. So let's coming into paper B. So the research presented in this paper addresses the issues of energy efficiency in IoT communication. It introduces a duty scaling cycling mechanism that enables devices to conserve energy by entering sleep modes during idle periods. The results demonstrate significant energy saving without compromising communication reliability. So this is the second paper which I have told now, and let's get into paper C. In this paper, the author explores the security challenges, IoT communication, and proposes a lightweight security protocol. So, in the paper C, the author has examined the various challenges related to the security, and they provided a solution lightweight security protocol. The protocol integrates authentication, encryption, and access control mechanism, ensuring secure communication devices and IoT OS. So the author has provided a basic information. What are the security challenges which you will be facing? So based on that, the there need to be a proper encryption of the data, and the and also authentication is also helpful because there is a chance that unauthorized user has access to the information, which will be really causes the data hacking and causes the data breaching. So authentication, uh, encryption, and access control mechanism. Access control mechanism in which comes like who are the certain people who can access the data or the file or the communication who can access those can which tells about the access control mechanisms. So when coming to UAVs offers a pro, promising solution for dependable IoT Internet of Things connections due to their mobility, flexibility, and temporary communication networks. And in a swarm settings, multiple UAVs form a dynamic network infrastructure, providing extended coverage, improved accessibility, and secure communication link. Scientific research confirms its reliability and tenacity. So this is a figure one which tells about the IoT equipments, standards, wireless subsystem, and best research for UAV swarm interactions. So we are three parts. A is A and B parts, typical IoT communication network and interaction subsystem that form of drone should be used. And when it comes to the figure two, this is the figure two, which is the easiest form is a free architecture for swarming UAVs that consist of base command software and easy swarm equipment comprising a bridge and hubs. This is the B, and this comes to the A, which is the easy swarm hardware, and it is the easy swarm ground control software. So when let's getting into the com comparing and constructing approaches, technologies, and challenges. So USS offer innovative solutions for ultra reliable IoT communications through offering improved scalability, coverage, and connectivity. Traditional research approaches such as paper A, paper B, paper C prioritizes each semantic interoperability, energy efficient communication, and robust authentication. And encryption protocols. The swarm use case with the UAVs offers a novel approach to communicate challenges and deeper approach of complexity of the research in this area. So this is about the comparison, constraining approaches, technologies, and challenges. Let's get into the next one. Conceptual framework for integrating IoT communications and operating systems. So in this, based on analysis of the research paper which I have done, and some uses a use case involving UAVs, this conceptual framework seeks to address the identified challenges and ensure enhances overall efficiency and reliability, incorporating connectivity and interoperability, energy optimization, secure communication, plus UAV swarm for extended coverage. The proposed framework consists of four unique components. The first component is connectivity and interoperability. So, in this connectivity and interoperability, standardized communication protocols such as MQTT and COAP enables data exchange between IoT devices and OS operating system. Additionally, employing semantic model and onto case. Interoperability is ensured among heterogeneous devices. Let's come to the second one component, energy efficiency and resource management. To man, to minimize the communication, minimize the consumption of the energy and also to optimize the resource usage, energy optimization techniques such as duty cycling, adaptive sleep models, and intelligent resource allocation are implemented. Ultimately, this enhances the longevity and sustainability of IoT system. As your energy efficiency is a major important which makes the performance better in the IoT devices by using the adaptive sleep modes and moreover duty cycles, which helps to make the energy optimization in this. These are the energy optimization techniques. So let's get into the third component, which is security and privacy. Robust security measures including authentication, encryption, access control, and data storage promise ensure communication between IoT devices and the OS. This is which makes the communication need to be protected and secure by following cut-in measures, something like authentication, encryption, and access control, which helps to communication need to be done properly. So let's get into the fourth one, common UAV swarm integration. The deployment of UAV swarms to deploy temporary communication networks, broaden coverage, and maximize efficiency in hard-to-reach areas and are blended into the frame. By introducing a swarm approach, reliability, fault tolerance, and adaptability in IoT communication is vast improvement. So in this figure 3, durability of one service network across Wi-Fi. This is the light blue color is the related to Wi-Fi. LORA is related orange color, which is showing is the LORA, and the LTE is the purple color, which you can see in the top. This is the diagram graph, something which is based on the reliability and distance. So in the figure 4, which is the UAV swarms positioning delay using LORA, Wi-Fi, and LTE separately. So here we can see the based on the polling delay and the number of drones. So in the LOR is we are indicating using the orange color, and when it comes to the Wi-Fi, we are indicating using the light blue color, and LTE we are indicating using the purple color. So this is the figure 4, which is we are representing by using. When getting into the conclusion of this assignment 4, ultimately research papers and the UAV swarm use case demonstrate the key themes, difficulties, and developments in IoT communication and operating systems. The proposed concept framework links connectivity, interoperability, efficiency of the energy and resource management administration, security and privacy implementation, as well as the union of UAV swarms to optimize the ultra reliable IoT communications. Through assessing these concepts, IoT implementations can tackle issues like scalability, heterogeneity, energy economy, and safety, thereby evolving operations, credibility, and the intrinsic potential of IoT techniques in the multiple fields. So these are the references which I have used, like which these are the help me to gain knowledge about this assignment 4, and which are used as the references here included here. Yeah. Thank you for giving this opportunity. Thank you.